Let's go over the review for exam 2. Question 1. A special deck of cards has 5 green cards and 3 yellow cards. The green cards are numbered 1, 2, 3, 4, and 5. The yellow cards are numbered 1, 2, and 3. The cards are well shuffled and you randomly draw one card. Part A. How many elements are there in the sample space? Well, let's consider our sample space. We know there are 5 green cards with the numbers 1, 2, 3, 4, 5. Let's list the green cards. We have 1, 2, 3, 4, 5 green cards. And then we also have the yellow cards. There are yellow cards numbered 1, 2, 3. So let's list the yellow cards. The yellow cards, 1, 2, 3. And so if you look at our elements, we have 1, 2, 3, 4, 5 green cards and 1, 2, 3 yellow cards. So altogether, the number of elements in our sample space is going to be 8. You add up all of the green cards plus all of the yellow cards, you get a sample space of 8. Now let's find the probability of E. The probability of E is an even numbered card. To find the probability of E, we look at the number of elements in E divided by the number of elements in our sample space. So how many cards are even numbered? I know there is a 2, a 4, and then another 2. So the number of elements that are even numbered is 3. And we know that our sample space has 8 elements in it. So we'll simplify 3/8. This simplifies to 0.375. And so that completes parts A and B. Question 2. Suppose that you're offered the following deal. You roll a 6-sided die. If you roll a 6, you win $19. If you roll a 2, 3, 4, or 5, you win $3. Otherwise, you pay $2. When the statement says otherwise, the only option would be if we roll a 1. If I roll a 1, I'm going to have to pay $2. For part A, let's complete the PDF table. List the X values where X is the profit from smallest to largest. So we want to make sure we're going to do it from smallest to largest. Round to 4 decimal places where appropriate. Now for the first probability, we are going to go with the smallest, which means I lose $2. If I roll a 1, I'm going to lose $2. Now, 1 is 1 out of 6. I have a 1 out of 6 chance of rolling a 1. So that will be equivalent to 1 divided by 6. And that is 0.1667. So round it to 4 decimal place, I have 0.1667. The second possibility is if I win $3. Now, in this case, I'm not paying to play the game. We have a deal. So if I roll a 2, 3, 4, or 5, I'm going to just win $3. I don't put anything to play the game. So we'll have a profit of $3. Now, what's the probability of getting $3? I have to roll a 2, 3, 4, 5. And that's 4 out of 6 possibilities, which gives me 2/3, and I can simplify that on the calculator. 2/3 is equivalent to 0.6667 rounded to 4 decimal places. For the last part, the most I could win is $19 if I roll a 6. The profit is $19 since we did not pay to win the $19. We just rolled a 6. And that's 1 out of 6 possibility. 1 divided by 6 is again 0.1667. For part B, we'll find the expected profit. To find the expected profit, we need to find the summation of x times p of x. Now to do that, we need to multiply this column times this column. So we'll make another column here, and we'll multiply x times p of x. The first one needs to be negative 2 times 1 over 6. The second one is 3 times 2/3. And the third one is 19 times 1 over 6. Now, you can use the decimal form. It'll work out the same. But I like the fraction form because I can easily enter it into my calculator. Negative 2 times 1 over 6 is equivalent to negative 0.3333. 3 times 2/3 is equivalent to 2. 19 times 1 over 6 is approximately 3.1667. Now, if we add all of this up, you get a number that's going to be your expected profit. And that is equivalent to 4.83. I'm going to round to the nearest cents. That's what the direction says. So we have $4.83 of expected profit. Again, make sure you add this column up, and you will get your summation of x times p of x, which is your expected profit of $4.83. Now, for part C, we'll interpret the expected value. If you play many games, you will likely win on average very close to $4.83 per game. In the long run, we're going to expect to make profit since this is a positive number of $4.83. Based on the expected value, should you play this game? Yes, we should play this game because that number is positive, so we're going to make profit from this, and that option is going to be this option. Yes, since the expected value is positive, you would be very likely to come home with more money if you played many games. Question 3. 60% of all Americans are homeowners. If 35 Americans are randomly selected, find the probability that A. Exactly 22 of them are homeowners. In this question, this is a binomial problem. I know it's a binomial problem because it gives us several things. We have a P, which is equivalent to 0.6. We're given an N, which is equal to 35. And we want to find the probability of exactly 22. So in part A, I'm looking for the probability of x being equal to 22. Now for the binomial probability distribution, we need to use this following formula. P of x equals n choose x, p raised to the x, times 1 minus p raised to the n minus x. Now in this question, I'm looking for p of 22. So we'll plug in a 22 here for the x, and for the n, we'll plug in 35. We have 35, choose 22 times 0.6 raised to the 22 times 1 minus 0.6 raised to the 35 minus 22. Now this looks complicated, but you can simplify it pretty easily with a handheld calculator. Let's simplify parts of it first. We have 35 choose 22 times 0.6 raised to the 22. We'll simplify inside the parentheses. 1 minus 0.6 is 0.4. And we'll raise that to the 35 minus 22. 35 minus 22 is 13. Now from here, I can type in the entire expression into my calculator. Now, if you don't have a scientific calculator, you can always go to Google and type in this input. So let's go to Google and type that input. Let's go to Google and we'll enter this directly onto the search, and it should be able to calculate for us the answer. So I want to type 35, choose 22, and you want to put this in parentheses. So 35, choose 22, and now we're going to put another set of parentheses, 0.6, raise that with the caret symbol, which is on top of the 6, press Shift 6 to get this symbol, and then we're raising this to the 22nd power, another set of parentheses, 0.4, and then again we'll raise that to the 13th power. Press search or enter, and you will get your solution, 0.304. So we have 0.1304 probability for exactly 22 of the 35 Americans being homeowners. This is equivalent to 0.1304, and that answers part A. Part A is complete. Let's try part B. At most 20 of them are homeowners. Now for part B, I'm looking for the probability at most 20. So that's x is less than or equal to 20. This is a very difficult problem if you were to do it by hand. If I want to find the probability of x less than or equal to 20, I would have to do p of 0, p of 1, p of 3, all the way to p of 20. And that is very, very difficult. Look how long it took us to do part A. You would have to do this 21 times. And that's too much work. So we're going to go to our statistics calculator. Let's go to the binomial distribution calculator. We are in our binomial distribution calculator. Let's put n, which is our 35 randomly selected Americans. This is the pi symbol here, the capital pi symbol, or the probability. So we want the probability, which is 0.6. And I want to make sure to click below. Let's click below, and I want to be below 21. What's below 21? Below 21 would be 20, 19, 18, all the way down to 0. So make sure you enter below 21 because 21 is not included. Click recalculate, and this is our solution for part B, 0.4272. Now that's one way to do part B. You can also click between, and I'm going to go from 0, since that's the first one, all the way to 20. And I guarantee you this is going to give us the same answer. It's going to give us 0.4272, just like before. That means part 2 is 0.4272. And again, we could do it by hand, but it's going to take us a long time. Let's use our statistics calculator when we have the opportunity to. For part C, I'm looking at least 20. The symbol for at least 20 is x is greater than or equal to 20. Again, we'll look for the probability that x is greater than or equal to 20. Now for part C, what does that mean? Well, it means the probability of x is greater than or equal to 20 is equal to P of 20, P of 21, all the way to P of 35 Americans. Now that's a lot of work. So let's go back to our statistics calculator again. We'll leave n the same, the probability the same, but this time I want to be above, and I want to be above, we'll enter 19. Because what's above 19? Well, the first number above 19 is 20. So click above 19 and select recalculate. This gives us 0.003. That's our solution, 0.7003. Our solution for part C is 0.7003. So the probability from x greater than or equal to 20 is 0.7003. Now we can try this problem a different way. Remember, greater than or equal to 20 is the same as from 20 to 35. So if I go back to my normal distribution calculator, I can also click between, and we'll put between 20 and 35 inclusive, and click recalculate. We get the exact same answer. So there's more than one way to do it with the binomial distribution calculator. For part D, I'm looking for the probability that x is between 17 and 22. Now, we're going to go to our statistics calculator again for part D. This one's easy to enter. We'll just put between 17 and 22. Press recalculate, and my solution is 0.6327. 0.6327. Question number 4. Use the spinner below to find the probability of getting the following number after one spin. The probability of a multiple of 3. To do this question, we'll look at the probability of event E, which is equal to the number of elements in E divided by the number of elements in our sample space. Now let's suppose E is the multiple of 3. That would be 3, 6, 9, 12. There are 4 possibilities out of a total of 12. In our sample space, we have 1 through 12, so there's 12 possibilities, and this simplifies to 1/3 or 0.3333. Question 5. A pizza parlor offers a choice of 12 different toppings. How many 2-topping pizzas are possible? No double orders of toppings are allowed. I have to decide, is this a combination or a permutation? And that's by determining, does the order count? In this case, the order does not count. The order does not count. How do I know that? Well, remember, a pepperoni mushroom is the same as a mushroom pepperoni pizza. So the order does not count. Therefore, this is a combination. It is a combination, so I need to look for n, and that's going to be 12, and r in this case is 2. So n choose r would be equivalent to 12 choose 2 in this question. We can go to Google to type in this problem. 12 choose 2 is equivalent to 66. That means there is 66 different pizzas. We can choose 66 different pizzas. Question number 6. How many different 5-card hands can be dealt from a deck of 52 cards? Again, in this question, I have to figure out, does the order count or does the order not count? Since we're looking at a 5-card hand, the order does not count. So this is a combination. I'm looking for 52 choose 5. Again, we'll go to Google to enter this into our calculator. 52 choose 5. This gives us a really large number. This number is 2,598,960. Again, that was 2,598,960. So it's very important that you find if the order does count or not. In this case, the order does count. It is a combination. In question 7, 20 runners enter the competition. In how many ways can they finish first, second, and third? Now, does the order count? Well, in this case, the order does count. How do I know that? Well, first place, second place, and third place are different positions. If I finish first, I would be much happier than if I had finished third place. So the order does count in this situation. We are going to use a permutation. Now, to calculate our possible ways we can finish, we need to know how many we're choosing from. I have 20 runners and I can finish in 3 possible ways. So we have 20 permutations of 3. We have 20 possibilities and we're going to pick 3 from that. So let's enter 20 P3 into our calculator. Our handheld calculator can do this. This gives me 6,840. There is 6,840 ways this race can finish. If you go to Google and type in 20 permutations of 3, unfortunately it cannot do it for you, but you can always go to the first link and type in 20 permutations of 3, and this website, Calculator Soup, can actually do it for you. It even shows you the formula they use to calculate it. That's 6,840. So if you don't want to buy a calculator, you could still use some websites that can do permutations for you. But of course, there's going to be some advertisements that you might not like. But it works. Question 8. Find the area of the shaded region under the standard normal distribution to the left of the given z-score. I want to find the probability of z to the left of 0.7. We'll need our z-table for this question. Recall, the area on our z-table is always to the left. So let's find 0.7 on our z-table. And here is 0.7 on our z-table. 0.7, and we'll need the second digit to be a 0, since 0.7 is equivalent to 0.70. And so the area to the left is 0.7580. And so the probability of z to the left of 0.7 is 0.7580. Now, if we were looking for the area on the right, let's say the probability of z being greater than 0.7, then I would have to subtract from 1. If I wanted the area to the right, I would have to subtract from 1. If I subtract 1 minus 0.7580, I get 0.242, which means the area on the right is 0.242. So pay close attention to the symbol. For this question, we wanted the area to the left, so we just use our z table. If we want the area to the right being greater than 0.7, we have to subtract from 1. So just remember, the table is always area to the left. Question 9. The combined SAT scores for the students at a local high school are normally distributed with a mean of 877 and a standard deviation of 162. The local college requires a minimum SAT score of 854 before students are considered for admission. What percentage of students from this school have SAT scores that do not satisfy the local college admissions requirement? Let's draw a picture so we can understand this question. We want to figure out what percentage of students will not be able to satisfy the local college admissions requirement. We know the mean is 877. We know the standard deviation is 162. And we know that the minimum score before a student is considered is 854. So that will be equal to our x. Now we can use the formula to calculate our z-score. Z equals x minus mu divided by sigma. 854 is our x minus the mean, which is 877, divided by our standard deviation, which is 162. This gives me a z-score of negative 0.14. We have 854 minus 877 in parentheses. Then I'm going to divide the entire expression by 162. And this is the same answer, negative 0.14. So we can do it on the Google calculator if we choose to. This is not our final answer. We have x equals 854, and we converted this to a z-score of negative 0.14. Now the question is, what's the area? We're looking for the area to the left because this is all of the individuals that will be rejected by the school. So let's go to our z-table and look for negative 0.14. Going to our z-table, we have negative 0.14 is located here. Negative 0.1 for the row. And for the column, we have 0.04. So let's intersect the row and the column to get 0.4443. So that's the probability. So we have this area is 0.4443. And so this converted as a percent is equivalent to 44.43% will be rejected. 44.43% of the students will be rejected.